The purpose of this video is to provide some help for the circular motion computer model. First off, please remember that the circular motion model is a lot more challenging than the projectile motion model. And so if you just want something easy, try the projectile motion. If you're looking to do a challenge and possibly earn a little extra credit, then the circular motion model is for you. And so first, let's take a look at what's our goal. What are we trying to build? So this is my circular motion model. You can see that there's an object at the center. There's a string which is pulling this object around in a circle. So it's moving at a constant speed, but it's always accelerating because it's changing directions. And that's what we're trying to do. Of course, our starting point is the unbalanced force model that we finished before break. So let's take a look at that. And so just to remind you, you can see my object is moving to the right and slowing down. And please remember that I use forces to create that acceleration, which is why it's slowing down. And you want to use forces for your circular motion object as well. And so let's kind of dig into this. I'm not going to show you my exact code for the circular motion model, but I will provide some hints. So one thing I would recommend, just to make it easier to keep track of things in your mind, is I would move that reference object that we created in the unbalanced force model to the center of your circle. And you can pick wherever you want, but an obvious place, an easy place, I think, is just at the origin. And so that's what I'm going to do. So the center of my circle is going to be at 0, 0, 0. And the next thing you want to do is think about, first, what's the radius of your circle? That's something you're going to have to know. And then second, draw a free body diagram for the circle. So if it's going around like on a string like mine was, what would that free body diagram look like? Okay, great. Once you know what your free body diagram looks like, we need to actually start calculating things like, for example, the tension force. And so previously we came up with these two forces, 1 and 2. I'm going to rename force 1 to be Ft. I'm not going to say right now what you should do with the second one, but that's something you should definitely think about. And so Ft can be, again, it can start as some vector, but later on, at least in the while loop, we're going to have it constantly be recalculating the size of Ft. And so somewhere in your while loop, you want to say Ft equals, and then you've got to figure out what it equals. So a couple new functions that we're going to need to help us actually calculate Ft is the mag and norm functions. So let's say if I do mag A, that's saying find the magnitude or the size of A. See up here that I initially set my acceleration to 10, 0, 0. And so mag A would be 10 because the size of that is 10. And so it completely ignores the direction. So this acceleration, because it's a vector, says it's 10 in x, so it's going to the right. But mag A just has size 10. And so, for example, you might want to do something like velocity times velocity in your calculation. But we don't want to care about the direction, so we just want really the size of the velocity times the size of the velocity. So a simple way to do that would be this is just saying the size of the velocity times the size of the velocity. One thing, calculate your tension force, you need to use variables, and so try not to use as few numbers as possible because variables make it just work a lot easier. The other function I wanted to show you is the norm function. If I did norm A, that would be a vector with vector 1, 0, 0. Because as you can see up here, I initially set the acceleration to be 10 to the right, and nothing up and down, and nothing in or out of the page. And so norm gives you a vector, but it always has size 1. And so it's basically just saying the direction only. And so norm of A would be 1, 0, 0 because it's going to the right, but it's not going up or down or into or out of the page. And so we're also going to use that to figure out directions. So for example, if you look at the actual circular motion object, the ball and the center of it, or the reference object, the displacement between them is always the direction that the force points, which is inwards. And so, for example, if you take the position of the reference object minus the position of the ball at any instant, that would be a vector that points in towards the center of the circle. And so that's how we know which way that the force, like let's say tension, should point. So, for example, this thing, norm reference object position minus ball dot position, it's always going to say point inward. So from wherever the ball is, it points towards the center, or the reference object. That's what I called it. And if we multiply this by some number, then that number pointing, so we could make a vector, for example, or a cylinder or something that points, has this size, 150, and it always points in this direction, the difference in position. So before you go farther, please try to calculate first on a piece of paper and then try to put the variables in the Glowscript model. What would your FT be? Another thing that you want to think about before you get too much farther is you need to make sure there's a particular relationship between velocity of an object moving in a circle and the acceleration and the net force. And you got to make sure that you have that correct relationship, or your object is not going to go in a circle. And then, so at this point, hopefully, you have a ball is going around the center, although you wouldn't have a blue string or anything to cause that. And so to make that object, you can just make a little cylinder or something that goes between the center to your object. And then you need to update the direction that cylinder points so that it always goes along with the object. One easy way to do that is in your while loop. If you write a statement like this, the axis is the size and the direction of which way the cylinder points. So mine, for example, is 150. And then times, again, this is the part that says basically it points inwards from the ball towards the center. That's what the norm does. So it gives it the direction. And so then all in all, when you get it running, should look something like this. Again, this is the more challenging model, so if you struggle with this and it isn't working, you can always do the projectile motion model is all that's required. But also we're here to help, and if you have questions, definitely stop by and extra help. Thanks and good luck.